Have you ever wondered how we can pinpoint any location on the Earth or why different places have different times? Whether it's the Tropic of Cancer or the Prime Meridian, understanding these concepts is crucial in geography. We'll also discuss how Earth is divided into different heat zones and how time zones work around the world. By the end of this video, you'll be able to easily locate places on a globe, understand how time is calculated, and much more. So, stay tuned and let's get started. In the last chapter, we learned something very interesting about our Earth. We usually imagine Earth as a perfectly round ball, like a football, right? But actually, our Earth is not a perfect sphere. It is a little flat at the top and bottom, that means at the North Pole and the South Pole. And it is a little bulge out at the middle, like when you press a soft rubber ball from two sides and it puffs up in the center. If you are finding it hard to imagine, don't worry. Just take a look at a globe, maybe the one kept in your classroom or at home. A globe is like a small model of the Earth. It shows you how the real Earth looks, with all the continents, oceans, and the slight bulge in the middle. So next time when you see a globe, remember, our Earth is not a perfect round ball. It's slightly squeezed from the poles and puffed up at the center. Globes come in many different sizes and types. This is important because our real Earth also spins from west to east, and that's why we have day and night. If you look carefully at a globe, you will see all the countries, continents, and oceans drawn on it. They are shown in their correct size and correct place, though sometimes we make very tiny adjustments to fit the globe shape. Now here comes a question. How can we find a particular place on such a round object like the Earth? It's not so easy, right? We need some special points and special lines to find locations properly. If you notice, there is a needle passing through the globe. This needle is fixed at a tilted angle, not straight up and down. This needle passes through 2 points, the North Pole at the top and the South Pole at the bottom. The globe spins around this needle, just like the Earth spins around an invisible line called the axis. But remember, on the real Earth, there is no actual needle. The Earth moves around an imaginary line called the axis, which goes from the North Pole to the South Pole. On the globe, there is one more special imaginary line. This line goes right around the middle of the Earth and divides it into 2 equal parts. We call this line the equator. Imagine cutting an orange into 2 equal halves. Just like that, the equator cuts the Earth into a top half and a bottom half. The top half above the equator is called the Northern Hemisphere. It includes places like India, the USA, Europe, and most of Asia. The bottom half below the equator is called the Southern Hemisphere. It has places like Australia, most parts of South America, and Africa's southern parts. Both halves, northern and southern, are almost the same size. Now remember, the equator is not a real line you can see on Earth. It's an imaginary circle. But it is very important because it helps us know exactly where a place is on Earth. Not just the equator. There are many more invisible circles drawn on maps and globes. These circles run parallel to the equator, all the way up to the North Pole and down to the South Pole. That's why they are called parallels of latitude. Each parallel tells us how far a place is from the equator. And we measure this distance in degrees. For example, if you go north from the equator, you may reach 30 degrees north, like India, or 60 degrees north, like parts of Europe. So, the equator and these latitudes are like the address system of the Earth. They help us find places easily. The equator is a very special line. It is 0 degrees of latitude. This is the starting point for measuring all latitudes on Earth. Now imagine that the Earth is a giant circle. The distance from the equator to either of the poles, north or south, is just 1/4 of the circle. So, to measure how far the poles are from the equator, we divide the full circle, 360 degrees, by 4. That gives us 90 degrees. So, 90 degree north latitude marks the North Pole, and 90 degree south latitude marks the South Pole. This is how we measure how far a place is from the equator. All the parallel lines above the equator are called north latitudes, and all the parallel lines below the equator are called south latitudes. When we talk about the exact location, we use either N for north or S for south. For example, let's take two places, Chandrapur in Maharashtra, India, Belo Horizonte in Brazil, South America. Both places are located on parallels around 20 degrees latitude. But here's the difference, Chandrapur is 20 degrees north of the equator, so we write 20 degrees, and Belo Horizonte is 20 degrees south of the equator, so we write 20 degrees S. If you look at the globe, you'll notice something interesting. As you move away from the equator towards the poles, the size of each parallel circle gets smaller. So, the lines closer to the poles are much smaller compared to the ones near the equator. There are some important parallels of latitude besides the equator, North Pole and South Pole. Let's look at 4 of these special lines. Tropic of Cancer, this line is at 23.5 north of the equator. It is in the northern hemisphere. Imagine this line as a boundary where the sun shines directly over the Earth during the summer solstice in the northern hemisphere. Tropic of Capricorn, this line is at 23.5 south of the equator. It is in the southern hemisphere. Similar to the Tropic of Cancer, the sun shines directly over the Earth at this line during the summer solstice in the southern hemisphere. Arctic Circle, this is a very important line at 66.5 north of the equator. It marks the area around the North Pole. In places near the Arctic Circle, there are times when the sun does not set for a whole day during summer. We call this the midnight sun. Antarctic Circle, this line is at 66.5 south of the equator. It marks the area around the South Pole. Similar to the Arctic Circle, places near the Antarctic Circle experience during summer months. These 4 lines, the tropics and the circles, play a huge role in how the Earth gets sunlight, which affects the seasons in different parts of the world. Now, let's talk about the heat zones of the Earth. You know, the sun is very important for our Earth. It gives us light and heat, which make life possible. But did you know that the Earth is divided into 3 main heat zones based on how much heat each area gets from the sun? Let's understand these zones. Torrid zone or tropical zone. This zone lies between the Tropic of Cancer and the Tropic of Capricorn. In this area, the sun is directly overhead at midday at least once a year. Because of this direct sunlight, the area gets the maximum heat from the sun, making it hot all year round. This is why we call it the torrid zone. You can think of places like India, Brazil, and Africa. They are located in this zone and are very hot and tropical. Temperate zones. These zones are located just above and below the torrid zone. In the northern hemisphere, it lies between the Tropic of Cancer and the Arctic Circle. In the southern hemisphere, it lies between the Tropic of Capricorn and the Antarctic Circle. In these areas, the sun is never directly overhead, but it still shines at a moderate angle, giving these places mild or moderate temperatures. This is why the weather in these zones is more pleasant, with cool summers and mild winters. Countries like Europe, USA, and Australia are in this zone, and they experience 4 distinct seasons: spring, summer, autumn, and winter. Frigid zones. These are the coldest zones on Earth. They are located in the northern hemisphere between the Arctic Circle and the North Pole, and in the southern hemisphere between the Antarctic Circle and the South Pole. In these areas, the sun does not rise high in the sky. The sun's rays are always slanting, meaning they don't provide much heat. Because of this, these zones are always very cold. Countries like Canada, Russia, and the polar regions are found in these frigid zones. These places have long, cold winters and very short summers. Now that we've learned about latitudes, there's something else we need to know to precisely locate a place: longitudes. Imagine two places, Tonga Islands in the Pacific Ocean and Mauritius Islands in the Indian Ocean. Both of these places are located at the same latitude, 20 degrees south, but we still don't know exactly where they are on the Earth. So, we need another reference to find their exact position, and that's where longitudes come in. What are longitudes? Longitudes are imaginary lines that run from the North Pole to the South Pole, cutting the Earth into vertical sections. These lines are called meridians of longitude. Unlike latitudes, which are parallel, longitudes are semicircles, half circles, and they meet at the poles. How do longitudes work? To measure the distance of a place in terms of longitude, we use a starting reference line called the prime meridian. This line runs from the North Pole to the South Pole, passing through Greenwich in the UK. The prime meridian is at 0 longitude, and from here, we measure eastward and westward. The distance between meridians is measured in degrees of longitude. The distance between meridians is wide at the equator, but as you move towards the poles, the distance between meridians becomes smaller and smaller, and eventually, all the meridians meet at the poles. At the North Pole and South Pole, all the meridians come together at one point. So far, we've learned a lot about latitudes and longitudes, but there's something important about meridians of longitude that we need to know. Let's break it down. Length of meridians. Unlike parallels of latitude, which are all different sizes, all meridians of longitude are the same length. This is because meridians are semicircles, so they are all equal in size, but this created a problem when it came to numbering them, because there's no natural starting point for longitudes, like the equator is for latitudes. The solution: prime meridian. To solve this problem, all countries agreed to start counting the longitudes from a specific meridian, the one that passes through Greenwich in the UK. This meridian is called the prime meridian, and it is 0 longitude. From here, we measure 180 degree eastward and 180 degree westward. Eastern and Western Hemispheres. The prime meridian and the 180 degrees meridian divide the Earth into two equal halves. The Eastern Hemisphere, east of the prime meridian. The Western Hemisphere, west of the prime meridian. So, when we talk about a location's longitude, we use the letters E, east, or W, west, to show whether it's east or west of the prime meridian. 180 degrees east and 180 degrees west. It's interesting to note that the 180 degrees east and 180 degrees west meridians are actually on the same line. They meet at the international date line, but we'll talk about that in another lesson. Locating places on the globe. Now that we know how to use latitudes and longitudes, we can locate any place on the globe. For example, let's talk about Dhubri, a city in Assam, India. It is located at 26 degree in latitude and 90 degree E longitude. To find this location, first find 26 degree N on the latitude lines. Then find 90 degrees E on the longitude lines. The point where these two lines meet is the exact location of Dhubri. How does time work on Earth? The best way to measure time is by observing how the Earth, the Moon, and the planets move. The Sun is the best timekeeper because it rises and sets every day. You can imagine how it helps us know the time by looking at the shadow it casts. At noon, the sun's shadow is at its shortest, and it gets longer during sunrise and sunset. This gives us a clear idea of the time during the day. Prime meridian and time. Now let's talk about the prime meridian, which is at Greenwich in the UK. When the sun is at its highest point in the sky at Greenwich, it's midday or noon. This means that at 12 p.m. in Greenwich, all the places along this meridian line of longitude will have noon at the same time. Now remember, the Earth rotates from west to east, so the places that are east of Greenwich are ahead of time, and the places west of Greenwich are behind time. How time changes with longitude? Here's the cool part. The Earth rotates 360 degrees in 24 hours, so it rotates 15 degrees every hour, because 360 degrees 15 degrees. This means the Earth moves about 1 degree every 4 minutes. If it's 12 noon at Greenwich, then places at 15 degrees east of Greenwich will be 1 hour ahead, because 15 degrees or minutes 60 minutes or 1 hour. So, if it's 12 p.m. at Greenwich, at 15 degrees east it will be 1 p.m. On the other hand, places 15 degrees west of Greenwich will be 1 hour behind Greenwich time, meaning it will be 11 a.m. there. And at 180 degrees longitude, which is directly opposite Greenwich, it will be midnight when it's 12 o'clock noon at Greenwich. Local time for every place. At each place on Earth, you can adjust a watch so that it reads 12 o'clock when the sun is directly overhead, which is at noon for that place. This gives you the local time for that specific location. For example, if you are in New York, at 12 p.m. it's noon there, but in London, which is 5 hours ahead, it would be 5 p.m. at the same moment. You can see that all the places on the same meridian, same line of longitude, will have the same local time. This shows how longitude helps us keep track of time around the world. Why do we have standard time? Imagine a country as big as India, where places on different longitudes, lines running from north to south, have different local times. The further east or west you go, the more the time changes. So, it would be super confusing to have a different time for every city. Real-life example of time differences. Let's think of Dwarka in Gujarat and Dibrugarh in Assam. These two cities are far apart in India. If you look at their local times, there will be about a 1 hour and 45 minutes difference between them because they are on different longitudes. Can you imagine how complicated it would be to run trains, buses, or even flights if each place had its own time? It would be impossible to create a simple timetable. Solution: standard time. To solve this problem, countries use a single time across the whole nation. This is known as standard time. Instead of using the local time of each place, we pick a central meridian, a specific longitude, to set the time for the entire country. India's standard time. In India, we use the longitude of 82.5 E, 82 degrees 30 minutes east, as the central meridian. The local time at this meridian is taken as the Indian Standard Time, IST, for the entire country. So, whether you are in Delhi, Mumbai, or Kolkata, the time will be the same. Why is this important? Having a standard time helps make sure everything runs smoothly across the country. Trains, flights, schools, businesses, and even news broadcasts all follow the same time, no matter where they are in India. It also makes international communication and travel easier because each country has its own standard time. In summary, standard time simplifies life by using one time for the whole country, and it helps avoid confusion in daily activities and schedules. Let's break down the time difference between India and England in a simple way. India is located at 82 degrees 30 longitude, which is to the east of Greenwich, where the prime meridian, 0 longitude, passes through. India is 5 hours and 30 minutes ahead of Greenwich Mean Time, GMT. This means that when it's दोपहर के 2 बजे in London, which follows GMT, it is already शाम के 7:30 बजे in India. So, if there is a cricket match starting at 2 p.m. in London, it will begin at 7:30 p.m. in India. Time zones around the world. The Earth is divided into 24 time zones, with each time zone covering 15 degrees of longitude. These time zones are created to help standardize time across the world, as the Earth is divided by lines of longitude, and time changes with each passing line. Russia is a large country, stretching over many longitudes, so it has 11 different standard times to account for the vast distance between the farthest east and west points. So, that was a comprehensive look at latitudes, longitudes, heat zones, and time zones. Now, whenever you look at a map or a globe, you'll have a clearer understanding of how different locations are related to each other based on their latitude and longitude. Remember, geography isn't just about memorizing locations, it's about understanding how everything is connected on our planet. I hope this video helped you get a better grasp of these concepts. If you liked the video, don't forget to like, share, and subscribe to the channel for more educational content. Keep exploring and stay curious. See you in the next video.